Previous lesson, you were working on using FOIL to expand two binomials into trinomials or quadratic expressions of the form ax squared plus bx plus c. Today we're going to look at the process in reverse. That process in reverse is called factoring. It's the opposite of expanding or FOILing. This lesson is all about factoring trinomials and quadratic expressions. So we'll look at the ways to factor some special quadratic expressions and some that are not considered so special, but still factor. The first one that we'll address will be one of our special patterns. This special pattern is called a difference of squares. Now, when you have a difference of squares and you were expanding, you found that the middle term dropped out. There was no plain x term. If you look at the examples, x squared minus 9, x squared minus 16, and 4x squared minus 25 are all of this format because they don't have any x term. And when you factor these, you're going to follow a rule. And it actually is the rule, maybe you recognize the pattern while you were expanding, but when you have x squared minus b squared, your factoring is going to turn out to be x plus b times the quantity x minus b. So x is your first term square rooted, and b is your second term square rooted. So let's look at these examples and do them together. Now every time we factor, we're going to start by setting up two sets of parentheses because you'll have a binomial times a binomial. And because our first term is x squared, that's the first thing we put in each parenthesis, an x and an x. Now, following the pattern, we need to put plus in one binomial and minus in the other binomial. Now, the last part is looking at the number term. The number in this case is 9. So the square root of 9 is 3, and that is the number that we'll put in the parentheses to complete the binomials. X plus 3 times the quantity x minus 3. Let's look at the second example. The second example is x squared minus 16. We'll start it with the parentheses again, and then we're going to put our x and our x. Since our first term is x squared, that's how they always start. Now, following the pattern, because it doesn't have that middle term, we're going to put plus in one binomial and minus in the other binomial. The last part is the square root of 16, which happens to be 4. So we'll put 4 in the first binomial for x plus 4, and 4 in the second binomial for x minus 4. Refoil it if you're not sure. You can always test it, and you'll find that that middle term drops out, and you have x squared minus 16 as a result. The last example here for difference of squares is a little bit different because instead of just plain x squared, it's 4x squared. But notice that 4 is also a perfect square. So we can take the square root of 4 and start our binomial with that. Put 2 in each parentheses. Since it's x squared, we still need an x for each in the first term. And then since we don't have that middle term, it's still going to be plus and minus. The last part is the square root of 25. Happens to be 5. So we'll put a 5 into each binomial for 2x plus 5 times the quantity 2x minus 5. And that is how you do the difference of squares for factoring. Now, some of the expressions you expanded were the form of x plus a squared or x minus a squared. They were like perfect squares. And they had a pattern in the answer as well. They all turned out looking as x squared plus 2ax plus a squared, or x squared minus 2ax plus a squared. So we're going to kind of look for the pattern. If you recognize it, it's wonderful. If not, the next technique can also apply back to these problems. So never fear. There's always a way to factor your expressions. So we're going to start with our parentheses. We'll take our two sets of parentheses down. And just like the others, we'll start with x and x. Now, the thing you want to notice about these expressions is that 8x and 16. Well, first of all, 16 is a perfect square. It's 4 squared. But 8 happens to also be 4 times 2. So, what we can do is we can say 4 times 4 for the last terms, which makes 16. And they're going to add up to 8. So we want to put plus and plus. So our expression becomes x plus 4 times the quantity x plus 4, which in your other assignment was written in a shorthand way with exponents. X plus 4, the quantity squared. Now look at the second one. It looks kind of like that. You can see that 25 is a perfect square. And if you think about the square root of 25, it's 5. So 5 times 2 is 10. So it follows the perfect square trinomial pattern. We'll start with our parentheses again. And we always start with our x's. So we'll put our x's inside the binomial parentheses. And then we'll put our 5's, because the square root of 25 is 5. Now, because it's positive 10 and positive 25, it's going to be plus. And you'll see in the next example why I say we can just look at the signs and see if it's plus or minus. The next one is x squared minus 14x plus 49. We put our parentheses down. We put our x's in. And then we look and we say, oh, 49 is a perfect square. The square root of that is 7. Twice 7 is 14. It must be the number. So let's put our 7's in. Only this time, we notice that it's minus 14x. So because it's minus 14x, we need to use minus for both of our binomials. Now that's all there really is to perfect square trinomials. If this is really confusing, think about the next method we talk about, bring it back to perfect square trinomials and try that. You'll see, it'll all work out. So the next method is when you don't have one of those special patterns, where you don't have the difference of squares, and you don't have a perfect square for the third term. In other words, you just have x squared plus bx plus c, or ax squared plus bx plus c. Now, to start with, we'll look at just x squared plus bx plus c, because it's much, much easier when x squared has a coefficient of 1. So the trick here is to look at the product of the numbers for the last term, the sum of the numbers for the middle term, and what two numbers will create that. So in the first example, the product is 12. And we'll just put that down here. That's the product we're looking for. It's always going to be the third term, or the value of c. The sum is the value of the middle term, or the x term, or the value of b. So in this case, the sum is 7. Now we need to think about two numbers that have a product of 12 and a sum of 7. What are those numbers? Well, in this case, 3 and 4. So the two numbers are 3 and 4, and that means we're ready to factor our expression. We'll bring down our parentheses, start with our two parentheses. Our first term is x squared, so we just put x to start with in each binomial. X and x. Next, we look at whether it's positive 7x or negative 7x, and positive 12 or negative 12. although we would have probably thought about that while we were thinking about our two numbers and our product and sum. So it seems like everything is positive, so I think we can add in both cases. And then put our numbers, our two numbers that we found, inside the parentheses to complete each binomial. So we can say that the quantity x squared plus 7x plus 12 factors to x plus 3 times the quantity x plus 4. And again, if you're ever unsure, FOIL it back out and see if you get your original expression. This is especially good in the next portion of the lesson. Looking at example 2, we have x squared minus 6x plus 5. So the product is 5, and the sum, this time, I'm going to take the sign with the number and make it negative 6. So we're looking for two numbers that multiply and give you 5 and add to give you negative 6. So if we're going to add the numbers to get negative 6, they have to be negative. So negative 1 times negative 5 gives positive 5, but negative 1 plus negative 5 is negative 6. Now that's okay if you don't guess the right numbers the first time. That's why we call it trial and error sometimes. So we'll bring our parentheses down, start with our x and x, and since it's negative 1, we're going to subtract 1 because the sign always goes with the number. So minus 1 and minus 5. And that would complete the factoring into two binomials of x squared minus 6x plus 5. Now, the last one is x squared plus 9x plus 18. So our product in this case is 18. Our sum is 9. So our two numbers that have a product of 18 and a sum of 9. So we can think of different factors of 18. For example, 1 times 18, or 2 times 9, or 3 times 6. So we want to think about which of those sets of factors adds up to 9. And it turns out it's 3 times 6. So we're ready for our parentheses. Bring an x down to start each one, because if we multiply first terms, we need x squared. Then we want to multiply last terms and get our 18, so that's our 3 and 6. And since we want to end up with a sum of 9, 3 plus 6 is 9, so it has to be positive 3 and positive 6. Now I have two more examples down here. First we have x squared plus 4x minus 32. So 32 is our product. Oh wait, it's not 32. It's negative 32. Bring the sign with the number. But our sum is 4. So now we need to think about two numbers. Of course, since our product is negative, one of those numbers has to be negative. That gives us a product of 32, but a sum of 4. So think about factors of 32, like 16 times 2, or 8 times 4, or 1 times 32. Seems like 8 and 4, one of those numbers has to be negative. If we take a negative 4 and a positive 8, that would add up to 4. But it would also multiply to give us 32. So bring down our parentheses, put our x's to start. That gets kind of routine. And that's kind of why we practice. We build routine. And then we're going to take our numbers. We're going to take minus 4, because we had a negative 4 as one of the numbers, and plus 8, because we had a positive 8 as the other number. If you want to check it, you can even just mentally take outside x times 8 is 8x. Negative 4 times x for inside is negative 4x. Add those two together and you'll get a sum of positive 4x. You can always check outside, inside, and make sure that you've set it up correctly. Now, this other example, both parts are negative. So now we have a product of negative 15 that we'll be looking for. And our sum will be negative 2. So now we have to think about two numbers that multiply and give us negative 15, but add together to give us negative 2. Think about the factors of negative 15. We could take negative 1 times 15, or 1 times negative 15. We could take 3 times negative 5, or negative 3 times 5. So we have to think about it, but what will give us a sum of negative 2? It looks like negative 5 and positive 3 will give us a sum of negative 2. So we're ready for our parentheses. We'll bring our parentheses down, start with our x's, and then we have to subtract 5, because negative 5 is one of the numbers, and then we will add 3, because 3 is the other number. Again, to check it, FOIL it back out and see if you get your original expression. Now all of these started with just x inside the binomials, because the coefficient for x squared is 1 in every example. In the next examples, which are the last form of expressions for today, we're going to look at ones where a is not equal to 1. In other words, you have ax squared plus bx plus c, but a is not 1. So looking at the first example, you see that a is 2. Now that becomes part of our trial and error, because 2 has to be part of that first term multiplication. So we have to bring a 2 down, and then we can bring our x's down. Now in the last examples, we looked for a product of 5 and a sum of negative 11. But this changes a little bit because our product is still 5, and the numbers still have to multiply to give 5. But now we have to check outside and inside and make sure it adds up to negative 11 when we're done. Since it's negative 11, I'm going to guess that the factors of 5 to use are negative. And I'm going to try minus 5 here in the first expression, and plus 1. No, not plus, because plus would give us a negative number, and we want a positive number for the end. So it should be the same sign. So minus, and then our other factor of 5, which is a prime number, so it's easy to pick, is 1. So at this point, I have 2x minus 5 times x minus 1. But I'm not sure if the 5 and the 1 are in the right order. They might have to be switched. To check, I'm going to multiply the outside terms and the inside terms. So, 2x times x is just 2x. And negative 5 times x is negative 5x. So when we put those together, excuse me, we end up with negative 3x, which is not negative 11x. So this time, We check outside and inside and find out that they didn't work. So the best thing to do is to switch the terms and try again. So we'll put the 1 in the first binomial and the 5 in the second binomial. Now we can try it again. Outside terms, 2x times negative 5x is negative 10x. Negative 1 times x is negative 1x. Add those together, we have negative 11x. So our check works. We factored the expression. Let's try the next one. 5x squared minus 2x minus 7. Now it's really nice when a is a prime number like 5 because there aren't any choices of what numbers to put in the beginning. We put a 5 next to an x and a 1 next to an x because 5 times 1 is 5. However, we generally don't write the 1. Now, our product is negative 7. So we need some numbers that have a product of negative 7. And then we have to check outside inside to make sure we get a sum of negative 2. Since our third term is negative, one of our factors will have to be plus, and one will have to be minus. Although I'm taking a guess at putting plus in the first one and minus in the second one. The only factors that we have for 7 are 1 and 7. So I'm just going to place those in there, kind of in a random order, and then check outside inside to see if we have our original expression, or our middle term, negative 2x. That's what our aim is. So 5x times negative 1 is negative 5x, and 7 times x is positive 7x. When we add those together, we get positive 2x, which isn't what we want. So we need to move things around. This time we have a choice of whether we move the plus and the minus, or the numbers. We might have to move both. But I think I'm going to try starting with the plus and the minus, because I ended up with a sum of positive 2 when I really wanted negative 2. So now once they're switched, we check again. 5x times 1 is 5x, and negative 7 times x is negative 7x. When we add those together, we get a sum of negative 2x. So we know we've got it correct. We don't need to check the first and the last terms because we created those. 5x times x is 5 squared. That's why we put that in there. Negative 7 times positive 1 is negative 7. That's why we put those numbers in there. So the first and last terms don't need to be checked. It's the middle term that needs to be checked. Here's one more where a is a prime number, 3. So we'll start with 3 in one of our binomials and 1 in the other, and then put our x's next to it. Now we notice our product is negative 2 and our sum is positive 1. Since our product is negative 2, one of our numbers has to be minus and one has to be plus. So I'm just going to place them in there, and we'll see if that's the correct order. The factors of 2 is a nice prime number as well, so there's not a whole lot of choice. We can use 1 times 2 to give us a product of 2. Quick check, does negative 2 times 1 equal negative 2? Yes, it does. Now we need to check outside and inside. So outside is 3x times 1, and inside is negative 2 times x. When we add those together, 3x plus negative 2x, yes, it is 1x. So this time, our trial and error was correct. We guessed correctly. Now, the last two examples have a little bit more trickiness to them, because if you look, the first term, a x squared, a is no longer a prime number. In these first three examples, we used 2 and 5 and 3, and there were no other factors of 2, 5, and 3 besides 1 in themselves. 8, however, has a couple of different choices for factors. We could use 8 times 1, or we could use 2 times 4. And just in my experience as intuition is pulled in, I find the smaller numbers are used more often. So I'm going to use 2 times 4 to begin with. But again, this is merely speculation, part of the trial in making an error. So here we have 2 times 4, and then we'll still bring an x down. We need that x times x to get our x squared in the first term. And now we're going to look at the rest of the equation, or the expression. It's minus 10x, but plus 3. And anytime your third term is positive, but your middle term is negative, you know it's going to be minus and minus. So that on your third term, a negative times a negative is positive. Now, we're lucky this time because 3 is a prime number. There are only 2 factors, 3 and 1. So I'm just going to place them down in here. And now we get to check. Does outside inside work? So let's check our outside. 2x times negative 1 is negative 2x. Negative 3 times 4x is negative 12x. Negative 2x and negative 12x happens to be negative 14x. Shoot. It's not the right order. So now we need to change our order. We can change our order by changing the 3 and the 1, or we can change the 2 and the 4. I think I'd like to try changing the 3 and the 1. So let's see what we get when we take outside inside with this. 2x times negative 3x is negative 6x, and negative 1 times 4x is negative 4x, and when we add those together we get negative 10x. So it does work. Let's take care of this very last one. We have 6x squared plus 19x plus 15. Now, 6 could be 1 times 6 or 2 times 3, but I think I'd like to start with 2 times 3 just as a guess. I usually start with the smaller factors. If they don't work, then I go back to 1 times 6. Put our x's in. And then we notice that everything is positive, so we're going to be adding. Now, we put 2x plus and 3x plus in each binomial. The last piece is to look at the factors of 15 and decide which ones we want to try. There's 1 times 15, and there's 3 times 5. When we think about 1 times 15, that means one of these two numbers in the binomial would be 15, and we'd be multiplying it by either 2x or 3x. That would get pretty big. I think I'll try 3 and 5. All right, we're ready to check outside and inside. So here's outside, 2x times 5, which is 10x. And then 3 times 3x, which is 9x. When we add those together, we do indeed get 19x. So, pretty good guesses. That's all for today. So let's look at our assignment. On page 40, work the problems in the left column. On page 41, work the problems 1 through 7 only. On page 43, please do all of the problems. And on page 45, the left column is sufficient. Work well.